Hello, everyone. I'm Neha Sethia Nagpal, developer advocate at Zite, and I'm super thrilled to kick off our first event of the year. Before I introduce our amazing speaker, let me share something that makes me incredibly proud. Our Extract Data Discord community has grown to over 14,000 members, and last year was truly remarkable for us. We hosted over 50 virtual events, bringing minds together across time zones, and launched our first ever US based Extract Summit. And together, we touched over 4,000 attendees. And thanks to you all who light up these events with your presence. And the energy was so incredible that we have expanded that to local chapters in Brazil, India, and Pakistan. So do not miss out on our upcoming events. You can add all of our events to your calendar. I'm sharing the link in the chat. Um, yeah, here's the link. You can add all the upcoming events. You can read about them, the title, description, add them to your calendar. And before we dive in today's session, just a quick housekeeping notes. Please use your Q&A feature and not the chat for any questions you have during the presentation. We will have a dedicated Q&A session at the end for a focused discussion, and we are recording the session, so you don't worry, all the registrants will receive the video afterwards. And now I'm super excited to introduce our speaker. Welcome, Theresia Tinzel. She's a true veteran in web data space. Theresia's journey at Zite is fascinating. She started as a Scrapy developer, went on to lead solutions architecture team, and then solution and sales operations teams as well. And now she brings her wealth of experience to industry analysis and content development. She's going to share insights from Zite's 2025 industry report on web scraping that you don't want to miss. So, Theresia, the stage is yours.
Thank you, Neha. Should we be sharing the slide?
You want me to share?
Yep, please.
Yeah. Wait. Sorry.
And Karen, we're going to go for an hour. So yeah, in 55 minutes.
Just give me a minute.
Okay, so while waiting, right, in the next 40 minutes or so, we'll be looking at a couple of the interesting points from Zite's 2025 industry report on web scraping. So if you haven't read the report, don't worry. You can take today's session as a good entry point to start delving in later. We'll highlight just a couple of key aspects worth considering this year and what they mean for you. Whether you're a web scraping developer, you're a data buyer, or you're selling the scraping tools and services right now. Cool. Okay, now we have the slide. Specifically, we'll talk about these 4 points, right? AI for data, which is how AI is impacting the space. Then we'll talk about DIY or delegate, which is in relation to tackling the scaling challenge. Then we'll talk about the factors behind the shifting economics of web data, which will determine your decisions to either buy or build the web data. And we'll bookend that discussion with data for AI, of the things we're seeing happening for web data in its relation to the AI use cases. Now, first, a bit about my background. As Neha quickly introduced there, I got into web scraping in 2012, so close to 13 years now. And I'm really glad that Scrapy already exists around that time, because it made my life so much easier. It also eventually led me to join Zite back in 2015. So I've had the front row seat and privilege to see how the technology and the business in the web scraping space have evolved. And based on this experience and perspective, I know that it's really not an understatement to say that we are moving at a crazy yet exciting pace. And I tried to capture most of what we see in this report. Let's start with the first thing we cannot not discuss, right? AI. So in short, let's look at the first we'll look at the impact of LLM boom on web scraping. AI is not know that ChatGPT, at that time, GPT-3, right, had unlocked the AI to the mainstream. And web scraping or web automation is one of the huge area with obvious opportunities for AI application. We started seeing an uptick of people Googling for scraping with AI around that time as well. Now, LLM brings the fun, right? In theory, we now live in a world where accessing web data is almost as simple as prompting it in human language. But if you try anything hands-on in this area, you'd have realized that the actual operations are far messier. Now, let's rewind 2 or 3 years before that, before 2022. We all saw a trend that we see like no code this, no code that, right? We saw an influx of low code tools and services on websites like Product Hunt. Now, to be clear, visual scraping tools have already been around since the beginning, even back in 2015. But this combination of awareness and adoption of low code tools and the AI powered tools have really lowered the barrier to entry. And we definitely saw this explosion last year. But so what? So what if web data collection is now democratized, right? So what if more people are able to scrape the web? Now, it's both a bad news and a good news. Let's start with the good news first. The good news is that the pie of web scraping services is getting bigger. The TAM, the total addressable market, is growing. Another good news is that it's absolutely great to see all these requests for small, simple, freelancer-friendly scraping projects can now theoretically be tackled DIY by the end users. Now, moving on to the bad news is that as we know, as more bots pull, more website would push. And this leads to the scaling problem, which we will actually talk about more in the second slide. But now we have ourselves a situation. While scraping itself has become easier, scaling is becoming more challenging. And the reality is most of these AI-powered scraping solutions don't scale well, at least not yet, right? And a huge underline on the not yet. At small scales, these tools are really a nice, frictionless way. They work seamlessly. You can look at the many YouTube tutorials for web scraping with AI posted in the past year. You can scrape a page, you can extract data points just by prompting them in English and other languages that you use. But once you increase the volume, the real difficulties emerge. Suddenly you'll be dealing with like rate limiting, captchas, IP bans, sessions persistence, infrastructure costs, all those, So to be clear, AI assisted scraping, they won't remain a small scale solution forever. We are really seeing how these LLM power tools are starting to integrate features that's more sophisticated to tackle the scaling aspect. They are adding session management, they're adding browser management, they're adding proxy handling, but for now, they still don't scale that well. So for now, aside from prompting, you likely need to juggle the different proxy, browser, infrastructure services using different API, do your own trial and error, and you do your own maintenance, right? But I do expect some Red Queen effect to apply to this dynamic. Anyone who can commoditize scraping will eventually capitalize on scaling. Now, switching to the ugly point, right? One of the most discussed aspects of AI-powered web scraping is the cost. Running the LLMs and machine learning-based extraction models is still more expensive than the traditional scraping methods. These AI models, they require relatively high computational resources. Whether you run it locally or you use some cloud-based services, it's still very considerable, the cost. During one of our cost comparison exercises, actually, we discovered that LLM-based extraction can be 50 times more expensive than the simple rule-based approach like CSS or XPath selectors. You can check out Ivan Sanchez's webinar. He's our data scientist at Scite, and the webinar is linked in the report. But in the webinar, Ivan demoed a real-world scenario of AI versus traditional scraping and extraction. Now, the reason of this cost discrepancy is straightforward. Traditional methods, they use a deterministic approach to extract the structured data with minimal computation. While the LLMs, they need to process like the whole chunk of at least a considerably larger chunk of content to be able to do the extraction. So this makes AI scraping a tough sell in scenarios where the data is already sort of well structured. Now, let me say that it's in some cases you do need the intelligent crawling, but for most cases that at least that we see at Zite, if you see three things to be true, which is if you knew which page you need the data from, you get to the second is you know how to get to the pages, and then the third is what you need to extract from the pages, then it really makes more sense to not use the AI-based crawling and extraction because it's deterministic. You can just code it in and it's going to cost less, right? So using an LLM in this case would be a good approach. It's still, there's some, a case you can argue for using LLM in those cases. If you have a limited technical resource to kick off the project, you only want to do a POC, a quick hack together, a short-term project. But if you're looking to for anything like a longer time frame or a higher scale, it's definitely an overkill. And another big point to make here is that the cost is dropping fast, right? We know all the development, even in the past month, right? We know the language models are really getting cheaper, they're getting smaller, they're getting smarter by the hour. So these developments, the cheap, small, pretty smart open source models, they're being released left, right, and center. They can help in code generation, they can help with reasoning tasks, but you have acceptable quality considering the cost. So the cost is going to drop. This whole dynamic is going to, go that way. Now, this is all a trade-off. We talk about when it makes sense to use AI, when it doesn't, but there are use cases where AI is really the best tool for the job. This leads to us to the last point, which is you need to make sure you're using the right AI for the right problem. Because we know by now that LLMs are not silver bullets. They're best suited for unstructured data, but using them for structured data is, again, like overkill, like using a sword to kill a mosquito. It looks cool, but it's kind of silly, right? Now, we know that the LLMs, they excel at processing patterns in language, but they're an overkill for structured data extraction. Again, not to belabor the point, this actually leads Zite to an approach commonly known as composite AI. So it's an approach where you combine the different AI approaches, so AI techniques, as well as the rule-based approach. So basically, we can combine the flexibility and power of Scrapy-based approach or any other crawler, a scraping framework that you might use. You can combine the flexibility and power of that deterministic approach. And then we also combine it with our own patented supervised models to extract the semi-structured data for some common data types. And then the last, we have the LLMs integrated into the crawling and extraction stack and workflow. So we tackle the end-to-end, like from structured to semi-structured to unstructured data. And you can do all sorts of, creative project, very flexible, very powerful. Now, all these layers, they also have very different cost components. For this, you can go see one of the talks in our Extract Summit last year. Chief Product Officer, Zite's Chief Product Officer, Ian Lennon, he talks about this in his session. So the talk is also linked in the report, so go check that out later. Okay, we have went like 15 minutes maybe, and we can go another hour talking about AI for data and web scraping. But if you're wondering now, how and when exactly can you apply AI in your stack? Go check out the report, find the section where I break down the AI adoption across 10 building blocks of web scraping stack. We also talk about something called the complacency trap. We made a case for unscalable scraping, so read the report later. Now, going to the the second slide, which is the DIY or strategic delegation, as promised, we're going to go back to the scaling challenge. Earlier, we talked about how as more people scrape, this will inevitably cause more websites to push back. And sure, there has always been an arms race in the space between the websites and the crawlers, right? But anti-bot techniques are really becoming sophisticated. We've seen a rise in the use of mouse movement intelligence and other more aggressive detection techniques. This has led to what I call the Turing tango. It's now a dance between AI. It's AI versus AI. So it begs the question, do you go manual DIY or do you pick your AI player for the battle, right? But to go a bit more concrete, right? There's still absolutely a place for those of us who are technically inclined, who want to go DIY without tapping into AI, and you can orchestrate your own scraping symphony, manage your own proxy pool, browser farm, army of crawlers, because we have to admit, there's some thrill and pride found in fighting bans, tinkering with your scrapers. But if we want to work smarter, then we need to ask the question, when does it make sense to go DIY and when is it smarter to delegate? But to answer that, we need to ask, delegate which part really to which services, right? To answer this question, it's helpful for us to first understand what are the different types of API commonly used in web scraping. In the report, we go deeper into the 4 common types, and we don't have the time to go over them, but in the report, we also give like a breakdown of the difference between orchestrating the different APIs and having something called the full stack web scraping API. So there's a clear convergence towards that full stack web scraping API. It's one endpoint that covers everything, all the functionalities of the different types of APIs. So you can handle everything from crawling, extracting, ban management, everything you might need in doing your own web scraping. So Zeit's own Zeit API is one example of such an approach. And in the report, we shared some pros and cons between the orchestrating the multiple API and using the single approach, right? And if you think about making the transition from the DIY to the gradual delegation, then usually everyone would need to bust some myth, their own myth, or do some mindset shift around pricing. One common misconception around pricing that I think is changing, especially this year, is that the managed solutions are always more expensive than DIY scraping. Of course, it really depends still where you are in the data journey. So at a pilot stage where you're still figuring out what your data needs, you're still experimenting with the schemas and so on, it does make sense to go DIY. But as you scale and your requirements are more solid, and if you consider the engineering hours spent maintaining, creating the crawler, infrastructure costs for running the operations at scale, and the opportunity costs of failed extractions, then the DIY solutions actually can get really expensive really quickly. Now, some APIs like the Zeit API, they can help abstract those key engineering tasks away. And infrastructure cost-wise, the pricing is also tied to the complexity of the websites. So it allows you to pay only for the complexity that you need. Basically, the pricing model scales with your needs. Okay, the last thing I'll say on this slide is that the key is knowing when to tinker and when to delegate. So if your data project is at a stage where it requires low-cost experimentation, DIY scraping, you have more control, right? It might be the best choice for now. But if you've matured to a stage where you need the reliability at scale, some compliance assurance, and you want to reduce some maintenance overhead, then a full stack web scraping API or a managed data service could really be the best option. Okay, while we're on pricing, actually there's, let's shift gears to data buyers. Okay. Okay, the underlying economics of buying and getting data has shifted. I don't know if you noticed the past couple of years, there's a clear change of the trend of how data marketplaces and the AI efficiencies are really changing the economics there. So we expect to see it more prominently this year, and the economics of buying data is really catching up with the cost of building in-house data collections. So this classic question of do I buy or do I build the data has been a fundamental question for data buyers. Now, with the rise of data marketplaces and AI efficiencies, the cost gap between those in-house solutions and the third-party services has narrowed. Traditionally, the companies with the technical expertise and the resources, they would lean towards building their own in-house solutions because the flexibility for customizing the control and the security compared to the perceived risk and challenges of working with third parties, external systems, it justifies the decision. But if there's now a one conversation that's worth revisiting in our data strategy, it's this conversation. What percentage of data collection should be built in-house and what should be outsourced? This is, if you haven't had this conversation or you haven't reflected on this kind of proportion of buy versus build in your current data portfolio, this is the time to revisit that question. Let's go to several key trends that's driving this shift. We talked about data marketplaces and AI, but let's go a bit deeper. So you can definitely find more tools right now to handle the scraping and extraction tasks that used to require somewhat dedicated engineering resources. We talked about the AI tools, and because of this, usually software is always cheaper than a headcount, then this became more cost effective. But beyond the cost, there's an interesting phenomena that AI and LLMs are unlocking. They are actually redefining what is possible with web data. It's now possible to extract data from complicated layouts and text, technically speaking. And then it also makes the data cleansing and post-processing tasks like matching, deduplicating, they're much easier now. Okay, so we talked about AI efficiencies, and then the other factor is the data marketplaces, right? A growing number of data providers, they now offer off-the-shelf data sets that's tailored to specific industries and your own niche, your own use case. And these marketplaces has been around for a while, of course, right? But they're really growing in numbers. And these data sellers, they allow you to access data on demand without having all the upfront, complex decision making, right? You can kind of pick stuff and kind of have immediate, like quick ROI. Now, both of these factors, they resulted in a lower upfront investment. Historically, setting up a robust data collection infrastructure, they require quite a significant upfront investment. They require some infrastructure, engineering talent to set it up, and then maintenance down the road, right? But today, companies can start collecting high quality web data with minimal setup costs. For example, some of you might not be aware that since the end of last year, Zeitz Data Services, we offer zero setup costs for data projects. So zooming out, like the bottom line is it used to be expensive and complicated to get web data, but now it's literally either a prompt away, some clicks away, or some calls away. So our recommendation is really two things. First, to reevaluate your web data sourcing strategy. And then the second is to revisit some shelf data projects, old projects that you have considered before, but you probably need to cancel or dismiss due to some technical or financial constraints. Now, the last part, which is I don't think we have time to go into, but in our report, we outline 3 stages of data buying journey. So this framework will help you determine your best approach of when to buy and when to build. Because at the end of the day, the understanding where you are in the journey, it's like everybody's data journey and data needs are very personal. So that understanding where you are, it can help guide you make the decision on how to allocate your resources between buying, building, or even maybe, you know, going something more experimental. So, okay, a quick recap. We have talked about a bunch of things. It's a lot, I know, in 30 minutes, but a quick recap. Like we look at AI for data. We look at how the scaling challenge created this demand for full stack web scraping API. And then we talked about cost of data acquisition. Now let's wrap up with data for AI. Okay, for this, we need to go into a bit of behind the scenes with what we see in Zeit's own business last year. So earlier last year, we anticipated a surge of data requests for AI-related use cases. In this, we mean people who want data to train some AI models. Now, we expected that surge, you know, but at the end of the year, AI-related data requests actually ended up really small in our pipeline. It's relatively small number compared to the 59% of product data requests that we see. So I think, you know, judging from that small percentage, which is 5% actually. So you can see it's very small. We expected to be more, but I think the more interesting story is behind these projects' value. Now, the average deal value of these AI-related data projects, they're 3 times the average deal value across all of our data business last year. This suggests that while not many AI companies are already actively shopping for data, those that do, they are making significant investment. So when they buy big. And we expect this vertical to mature and the appetite to follow, you know, fingers crossed. But as of now, we offered a couple of ideas in the report again about why probably not many AI companies are already relying on data vendors. Okay, judging by the rate. Okay, let's move on to the next point. Okay. So judging by the rate of development in the AI space right now, anyone who tell you they know what's going to happen, they don't, right? Absolutely no one can predict or even agree on how this will unfold, like, and what kind of timeline we're looking at. But if we cannot bet on what's going to change, we should bet on what's not going to change. And I've been watching this space closely, and this is my conclusion. If there's only one thing that most AI researchers agree on, it's this thing, right? That your model is only as good as your data. So your data will either make or break your model. So either it's public web data, it's proprietary data, synthetic data, any other data that you can think of, you know, embedded model, embedded systems model data, and so on. But it's most likely a combination of every data. Basically, the success of a machine learning system, it ultimately depends on how well the data captures the detail and the complexities of the real world and our real lives, right? So think really be very careful of the quality of data that you're collecting, and think about what kind of data would give you an edge. So I think we'll end there. Go ahead and read the full report. It contains much more detail on every topic that we have covered today, and we have more. We haven't even gone into the compliance and legal stuff yet, right? And as Neha talked about, we have a community on Discord of over 14,000 members that you can join to connect with other web scraping enthusiasts and keep up with the latest trend in the space. So thanks for tuning in. we have a lot of times for Q&A. So yeah.
Do you want to take the questions, Teresa, or shall I read it for you?
Could you, yeah, where do we start? Q&A. Yeah, you can pick, Neha, please.
Okay. So this question is by Ishan Prakash. What is the best stage to leverage AI in the scraping journey? Once we have extracted the data points, and if we have the basic schema validation already in place, how exactly can we then leverage AI to get better at identifying mistakes in data we are grabbing?
The best stage to, yeah. Uh, if you have already a model, like if you have a quality data, like your training model, right? You want to compare what you get with what you think is good. So if you already have that, then you can do that, like training. You can fine tune the model to kind of tell you what your current data is missing. But if you don't have that good data set yet, the reference data set, then build that one. So I think that's a good starting point. If you
Yeah.
can follow up with any other, if you want to ask a bit more follow-up question, please go ahead, Ishan. But I hope
Yeah.
that helps.
I think like identifying mistakes could be like of various types as well. Like, we could have like, missing data, but then is the
Mm.
data that we are collecting, is the pricing correct? Is it like, timing of
Yeah.
all of those parameters also come in. So if you can just elaborate more on what kind of mistakes you are referring to, I think we can answer the question really well. Next question is from John Rooney. Do you think there's going to be a shift from build to buy, or with the comprehensive tool set, maybe it will be the other way around?
Yeah, this is very hard to predict, right? But I think we're going to see a mix of things happening because not everybody is going to shift from build. We see every scenarios right now. Some people are building more, some people are buying more. I guess probably it makes sense to look at it in terms of the verticals, right? Maybe in some verticals there are more data marketplaces that's catering to those. Then maybe in those cases it's going to be, make more sense to buy. But I think it's going to be very case by case.
The next is from an anonymous attendee. Is it possible to give a demo on how data can be scraped from any site using LLM?
Oh, definitely we have a lot of webinars around that. So yeah, maybe Neha can, check out the Discord. I think we have a list of webinars there. But yeah, Neha, if you want to add anything here.
Yeah, so we have like a lot of webinars done like already on the same topic. And you can join Discord if you aren't part of it. And there's a events archive channel. Like I'm pasting the link in the chat. Um, where is the chat? Okay. Yeah. I'm posting the link in the chat to Discord. So join the check the events archive channel, and like you'll find the videos of all the events that we have hosted. But yeah, it won't be possible now to give you a demo. But then like Zeit AI scraping is worth checking out, and we have tutorials on docs.zeit.com as well. So next question is from Dan. What is the tipping point for it being worth using AI in scraping versus just writing a good old scrapey spider, and what are few proxies on it? Is it the number of sites, size of schema, how often the sites break, priority of cost per request?
We need to answer this question with an article, I think. Because it's very, the tipping point for worth using AI. And again, this begs the question, which AI? Because if you need, for example, you have a broad crawl project where the number of sites is more than 100, then it immediately became clear, you need to, there's no unifying, it's a lot of layouts, so and so on. So definitely these like number of size of schemas, how often do they break, do you expect them to break, and cost per request, these are all really good considerations. But like to have one tipping point, I think it's very hard to draw that line.
Another
Mm. Mm.
Another another question is from again an anonymous attendee. What are key data qualities measures for diverse large-scale web scraped data?
Key data quality measures for diverse large web scrape. Oh, okay. So how we measure quality, is that what you mean? If it is, we usually do like accuracy and coverage, right? And accuracy, it can be the item accuracy. It can also be the item and then field accuracy. And we have the same kind of coverage for item and also the field. So I think we have a couple of articles talking about this, but yeah, those are basically kind of like two things, but with two dimensions, two sub-dimensions. If it's not clear, please ask another question. Yeah. Mm.
Yeah, I think like our data quality assurance process have like 5 dimensions to it. Like I'm not able to get the blog out, but I'll do share in the community on this. We've written a detailed blog about this, the
Oh.
data quality dimensions that we follow. Um, Next question is, how do we go about implementing CAPTCHA solvers? I've seen some website forcing you to solve CAPTCHAs to access them.
Usually I don't recommend, like we don't, that's not the best practice actually, solving the CAPTCHA. The best would be just to avoid the CAPTCHA. So you would even don't get the CAPTCHA, that's the best solution, because once you get it, then it's another level of difficulty. But if you can manage your own session, your proxy, that would that would kind of help you not face the CAPTCHAs. But definitely we cannot like give a tutorial right now for how to create a CAPTCHA solver, but there are more materials out there around solving CAPTCHAs. But yeah, my recommendation is just avoid them.
Or use Zite API.
Yeah.
What is origin of term Turing Tango in a context of evolving interaction between AI-based anti-bots versus AI-based scraping?
Right. Okay. I'm glad someone asked this question because I wanted to elaborate on it, but I wasn't sure of the time. But basically, you heard of Turing test, right? Where it's a test to, let's say, the bot, a program is going to be deemed to be Turing test, passing the Turing test if it can convince us human that it's also human. So it's like as human as possible, then that's Turing test. Now, Turing Tango is something I just invented where it's the AI or the system or the program is going to be acting like a human, but it's going to face another program that's acting like a human too. So that's like the bots versus the websites, or even like the defender and the crawler, something like that. Let me know if it makes sense, but yeah, that's the origin.
I think next question is, web scraping can be difficult, especially due to frequent changes on XPath and IP blockage. How would you handle this problem?
Yeah, this is definitely a scaling problem, right? Check out Zite API.
Yeah. Now, Ishan has some follow-up questions. Do you want to take it up? Yeah, I think we can.
Okay. Okay, so if I just have validator in place that use LLM to check whether my data is correct, how accurate will, sorry, if there's a background noise, accurate will AI validation be? If you can if you scrape the web page and then you store it, then you can definitely, I think this is a problem more when you don't know what the actual web page was showing at that time, because you cannot compare, is this accurate or not? But if you are, then it's easier, and then you can manually spot check. So what if it gives false positive? Then I think it's tuning either the prompt but yeah, again, if you have the source of truth, like the actual HTML, let's say, then it's easier to spot these false positive, because LLM, they can process and they can give you what they think. I think most of the problem with LLM extraction is they would make up things that's not on the web page, right? Now that's the biggest, I think the biggest risk, I should say. So if you have the original, you can check, okay, is this even in the web page, or is this hallucinated, right? Okay, so the second point, for example, when it comes to stuff like price and other details, does the cost justify the improvement in data quality? How do we balance AI validation cost and risk? This goes back to the business value that you get from your data. If you're not getting any money, in a way, you're not getting the actual monetary value from the data, or you're not, basically, what's the risk? What's the monetary risk for you if for incorrect corrections? Because that would kind of help you make the calculation to justify the improvement. But I think, I don't know your specific case, but I think iterating on your LLM, like the improvement and so on, is quite low cost right now. Depending on your use case, whether you're like processing a huge web page or not. But I think it goes to what's the value that you're risking here. Okay, I'll go on to the next question. Okay. Could you suggest some AI agents trained to handle requests like human? AI agents, any of these platforms like Crew.ai and so on, they can. Okay, I just saw you stopped sharing. But AI agents trained to handle requests like human. All of them are designed to handle requests like human. Maybe you can be kind of clarify what you mean, like handle requests like a human. And then Karen, what is the general cost of strategic delegation for your business and cost to maintain and improve ongoing scaling? General cost of strategic delegation. General cost of strategic delegation for. So the average cost, the general cost of data projects, is that what you're asking, Karen? Because okay, if you're delegating to API, then the cost would be the minimum like subscription per month, that's lower on the API side. But for managed data, that's usually higher than that because it involves some engineering time. But I'm happy to continue this discussion because I think there's a lot more beyond this question, but I cannot get to it right now. If you want to give another follow-up, like clarification of the question, Karen, that would be great. Ma'am, I learned Scrapy and Selenium to scrape the data, which is best no code for this. Yeah, I think a lot of these open source, you can scrape graph API, scrape graph AI. That's one, that's gaining about a lot of traction. That's open source. No code, yeah, a lot of them actually. You can Google them and try them, but there's a lot of options these days. Actually, in the report, I mentioned a couple. So yeah, find the list there. So there are no other questions.
There are some questions people are posting in the chat.
Okay.
Like we're running out of time, and I think like for those who have questions and they're not yet answered, like, and if you have follow-up questions on this webinar, we have a forum, dedicated forum in Discord created just for this webinar. So you can post your questions there. Let me just quickly share that with you. You can just go to the events archive and have them. Yeah. So you can see that you can post. Okay. Yeah, you can just find the link to that channel in the chat, and you can post all of your queries um, in that forum. And that's it. Like, thank you for everyone. Thank you everyone for joining in today. And thank you so much, Theresia, for giving a quick start on the Web Scraping 2025 industry report. And I'm sure like we will have learned a lot from it. And like, if you want to dig deeper onto the topics that we discussed today, just give a read to the report. And we've shared the link in the chat already. And yeah, so as I mentioned, like we have a couple of events lined up. Next week, we have another event. You will find all the details in the calendar. So make sure you join them. And have a nice evening. Thank you.
Thank you.
Thank you so much, guys.